Welcome to Compound Inequalities, Part 2. Talked about and her marshmallow tests, but we haven't talked about interval notation. Interval notation is another way to show the solutions of a compound inequality. In this example, we'll start with x is greater than or equal to 2. So here's 0, here's 2. If I want to show all the numbers that are greater than or equal to, I'm going to shade in with a solid or closed circle, and we're going to shade to the right. Now, to write that in interval notation, what you do is you kind of like start from the left side of the screen, start from over here, and what's the first thing we see? I see right here, we see the number 2. So that's going to be the first thing in my interval. And because we have a closed circle, to indicate that we use a bracket. And as you see, as we go from left to right, it just keeps going forever and ever and ever to infinity. So the next number on this interval is infinity, which looks like a sideways 8. Not very neat in my drawing, but I think you guys get the idea. And since you'll never ever actually get to infinity, we use this parentheses. So the bracket symbol is closed circle, parentheses is like wherever you see it around infinity, or whenever you see it around an open circle, like a number 2. X is less than 2. Alright, so let's do the same thing. We have 0, we have 2. Since it does not have a line underneath, that's an open circle, and it's a less than, so we shade to the left. I'm going to do my shading, and again, this is review. You guys should remember this, but to write the interval, we're starting from the left, and as you can see, all we see on the left is just shading. The line shades forever and ever and ever to the left, so I'm going to use parentheses, because the first number we're going to see is a negative infinity. Seems kind of weird, but yes, it's real. So since we're never going to touch negative infinity, we use the parentheses, and then we keep going left to right, and the last number we see is a 2. Open circle, so we use the parentheses here, and these are our intervals. Now when you have the compound inequalities like we have here, the intervals get a little bit different. So let me graph this. Start with 0. Here's 1. Here's 5. Right, x is literally between 1 and 5. So at the 1, since there is no line, I'm going to put an open circle. At the 5, there is an equal to sign underneath, so we're going to put a closed circle. X is less than or equal to 5. Shading will go this way. X is greater than 1, so the shading goes this way. And again, this is one of those and problems, so we shade in between. That's what our graph would look like. So to do the interval, you start from the left, and we see that's an open circle, so we're going to use parentheses on 1, and we keep going until we see the next number, which is a 5, and since it's a closed circle like we did up here, we use a bracket. Alright, last one. X is less than negative 3, or x is greater than or equal to 4. So I'm going to put negative 3 on my number line. Here's 0, and here's 4. Less than or equal to is an open circle. This is going to shade to the left. Greater than or equal to 4, that's a closed circle. So we're going to shade to the right. Alright, so there's our graph for it. This is an and. This is an example of an or. And to do the intervals, again, we start all the way from the left. We see shading and an arrow, so that means we are using a negative infinity for our first interval. This is an open circle, so at negative 3, we have parentheses. I am running out of space here, so I can move it up a little bit. That's good. Alright, so the next part about this is after we see the negative 3, we come to our next number is a 4, and because we have a closed circle, that's a bracket, and it goes all the way till infinity. right? And of course it doesn't touch infinity, so we use parentheses. So this whole combination is the interval of x is less than -3 or x is greater than or equal to 4. Alright, learning check time. What I'd like you to do is go back and look at your notes. You probably should have written something down about the interval notations, how to write intervals. You should have, if you're looking back to even part 1, you should look at how to solve and graph compound inequalities and the difference of and or. I'd like you to take a few seconds to go back in your notes. Just do it. I know I'm not looking at you, but just do it. I promise. It's good practice. You look back at your notes, kind of summarize in your head what's been going on so far. Make sure you understand everything. This is our learning check. You do that while I'm going to try to count the number of legs on this elephant. So hit pause. Did you hit pause? All right. Well, I'm back. And upon further investigation with the elephant legs, this is actually a duck. All right, now it's your turn. I would like you to try these problems. Give them a try, and in a few minutes, you're going to hit pause. I'll show you the answer to them. So give them a try. Put these on the bottom of your notes, and we'll come back to you. So I hope you tried these on your own. If you didn't, now again, hit pause. This is a video. You're allowed to do that. So if I were to solve this, I would subtract 3 from all sides. Again, it's like a variable party. And we're all invited. 8 minus 3 gives us 5 here. This gives us x in the middle. Bring down our signs. -4, -3, signs are the same. This is going to be -7. So I would graph this as, here's -7, here's 0, here's 5. Sorry, my handwriting is sloppy, but you guys get the point. Open circle on -7, open circle on 5. Shading is going to go between. So your graph should look like that. For the next problem, subtract 7, get 5x is less than or equal to -10. Divide both sides by 5, and we get x is less than or equal to -2. Now the other part for the or. By the way, we are dividing by a +5, not a -5. So even though this 10 is negative, this is not the special rule because we're dividing by a positive number. This next problem, we're going to add 2 to both sides. We get 3x is greater than or equal to 15. Divide both sides by 3. And we get x is greater than or equal to 5. So these two parts are a solution to this compound inequality. I'm going to do -2. Here's 0. Here's 5. So x is less than or equal to -2. That's a closed circle. And we shade to the left. And x is greater than or equal to 5. That's also a closed circle. We shade to the right. And this is another example of what ORs generally look like. Alright, so hopefully you understood how to do those problems. Your answers match it up. Take your time to check. We've already done this slide. And of course, this is me showing you that I can still scare you even though this is just a video. Ha ha. Alright, the last part about this. I would like you to summarize your notes. I will check those in class. Again, we're making these Cornell note style, so reread through your notes. Make sure you have those you try problems solved. And write 1 or 2 sentence summary on the bottom using the words, let's say, compound inequality. That's obvious. It'd be hard to summarize these notes without saying compound inequality. Quality. Use the and. Use or, and please explain something about intervals. Thank you. Hopefully we enjoyed our first attempt at online lessons. I will see you in class.